Hi, my name is Tiearea and I am a doctoral student at California Intercontinental University. And today I will be doing a presentation on chi-square testing. The agenda for this presentation will be to define chi-square testing, to identify when to use it, to give examples of how to interpret the testing using SPSS software, how to confirm significance finding using Framers V, how to point out key takeaways, and also give opportunity for asking questions. So what is chi-square and how do we use it? Chi-square testing is a non-parametric distribution-free tool designed to analyze group differences when the dependent variables are measured at a nominal level. Chi-square is a significant statistic and should be followed with a strength statistic when the findings are significant. The Kramer's V is the most common strength test used to test the data when a significant chi-square result has been obtained. The results of the Kramer's V interpretations are listed below. A finding of 0.00 will indicate there is no relationship between the variables. A finding of 0.00 to 0.15 would be a very weak relationship. 0.15 to 0.20 would be a weak relationship, but it is the minimum strength needed to claim a relationship. 0.20 to 0.25 is a moderate relationship. 0.25 to 0.30 is moderately strong. 0.30 to 0.35 is strong. 0.35 to 0.4 is very strong. 0.4 to 0.5 is questionably strong. 0.5 to 0.99 is redundant. And 1.00 is perfectly symmetric. And this finding is very rare. The dataset used for this testing was generated using a SurveyMonkey survey which asked participants questions regarding their income, debt, savings, and other important personal finance factors. The first chi-square test will compare the number of car payments participants have compared to the number of payments that they have in default. The second chi-square test will compare the comfort level of participants with their current financial standings, along with the amount of payments that they have in default. The third chi-square test will compare the number of monthly car payments along with the comfort level of each participant with their current financial standing. The first hypothesis test used a null hypothesis that stated there is no relationship between the number of car payments and the number of payments in default, with an alternative hypothesis that stated there is a relationship between the number of car payments monthly and the number of payments in default. The chi-square statistic and its p-value were calculated using SPSS software assuming a significance interval of 0.05. As a result, no relationship emerged as the p-value resulted in 0.351, which is higher than a significance level of 0.05. The second hypothesis test used a null hypothesis that stated there is no relationship between the comfort level of participants' financial standing and the number of payments they had in default. The alternative hypothesis stated there is a relationship between the comfort level of participants and their financial status and the number of payments that are in default. As a result, the chi-square statistics and its p-value were calculated using SPSS software with a significance interval of 0.05 and showed no relationship between the two, with a p-value of 0.351, which is again higher than a significance level of 0.05. hypothesis test, we use a null hypothesis that stated there is no relationship between the number of car payments monthly and the comfort level of participants with their current financial status. For an alternative hypothesis, we stated there is a relationship between the comfort level of participants and their financial status and the number of payments in default. The chi-square test statistic was again used with SPSS software along with the p-value using a significance interval of 0.05, and as a result, a relationship was shown with a p-value of 0.00, meaning that we needed to conduct a follow-up test to show the strength of the relationship. And for this, we used the Kramer's 5, indicating a perfect symmetrical relationship. I just wanted to show you the Kramer's V interpretation scale again. As you can see, 1.00 is perfectly symmetric and a very rare finding. The main takeaways from this presentation are that chi-square testing should be used to analyze group differences when the dependent variable is measured at a nominal level, and when the results are significant, a strength statistic such as Kramer's V should be conducted to identify the strength of the correlation. Please feel free to ask any questions if you have them, and thank you for taking the time out to listen to my presentation and observe it. I hope that you find it useful. Have a wonderful day.